Welcome to the December edition of our Down to Earth series of talks. Thank you for joining us for this event. Our presentation today is Asbestos in Soil, Risks and Management During Site Work. My colleague Emma Hobbs, a senior consultant in the contaminated land team within our Manchester office, will talk us through this topic shortly. However, firstly, a quick note on housekeeping. All participants will be muted and video turned off aside from the speaker. Questions will be through the questions function. If you have an issue with viewing the presentation, please raise your hand and our team will contact you. A feedback survey will be sent around following the presentation. Please take time to complete this survey so that we can continue to improve our Down to Earth series of talks. RSK Geoscience are part of the RSK group of companies. RSK provides support throughout the property and construction sector, including environmental surveys, asbestos surveys and management, ground investigation, engineering design and consultancy and structural design. The geoscience business includes ground engineering, contaminated land surveying, and of course, asbestos surveyors and consultants. So our talk today is Asbestos in Soil, Risk and Management During Site Works. As I mentioned, Emma Hobbs is a senior geoenvironmental consultant based in our contaminated land team within the Manchester office. Emma is a chartered scientist and a member of the Society for Brownfield Risk Assessment. Emma is a geologist by training and coordinates a range of site investigation projects from the Manchester office and has extensive experience of brownfield site investigation. However, I will let Emma give you some background on her role within the Manchester team and as lead for the geoscience business with regard to asbestos. So I'll hand over to Emma now. Thank you very much for attending.
Thanks for the introduction, Hugh. And hi everyone, welcome to this presentation. As Hugh said, I'm Emma Hobbs. I'm a senior geoenvironmental engineer working out of the Manchester Geosciences team. For the remainder of the talk, I'm going to turn off my webcam, which I'm going to do now, and then I'll continue on. So yeah, as Hugh said, my name's Emma, based out of Manchester. I previously worked for a consultancy firm called Capita Simon Structures, following which I moved to RSK in 2014. I've progressed there to senior grade, and I've most recently obtained my chartership status with the Geological Society. Currently, I'm a project manager working on a number of small to medium-sized projects, overseeing site work, site liaison and project finances. I'm also involved in delivering core internal training for asbestos in soil procedures, and I'm part of the QRA, the Qualitative Risk Assessment, and the PFAS subgroups for RSK, and I'm the technical lead for asbestos in soil practices during site work. So this session aims to give a brief overview of the guidance documents and practices we implement before and during in-ground investigations with respect to asbestos. I'm sure most people listening today will have had some form of asbestos awareness training and is aware of what asbestos is. So I'll keep that elements of the presentation quite brief, but I'll discuss in more detail the legislation and guidance documents that we use specific to asbestos in soil. I'll then go on and talk about how asbestos impacts the design and undertaking of an investigation throughout its lifespan, from death study stage through to intrusive investigations, where I'll talk about mitigation measures that we can implement throughout those stages. I'll then talk more about some remedial options and give an example of a remediation project that's centred around asbestos in soil. So asbestos is a naturally occurring silicate mineral which comes in 6 forms: chrysotile, amosite, crucidolite, and then the lesser known 3, which are tremolite, actinolite and amphipholite. The first 3 are most commonly found in the UK. Chrysotile, also known as white asbestos, is pictured on the right hand image, Amosite is known as brown asbestos, and that's shown in the left-hand image, and cricidolite is blue asbestos, which is the straight needle-like fibres. Asbestos use of amosite and cricidolite was banned in the UK in 1985, but use of chrysotile continued in such features as Artex until its ban in 1999. However, asbestos is still used around the world, for instance in the US, where it seems the financial benefits of using asbestos in cement pipes, for instance, outweighs the health effects. Asbestos has been so popular throughout history and is so widely found today because of its desirable physical properties, which include its good tensile strength, thermal and electrical resistance, fire retardant, and it's a cheap commodity. So asbestos is a carcinogen, meaning that it's an agent directly relating to cancer. There are three main types of asbestos diseases caused by exposure to asbestos. Mesothelioma, which is a cancer of the cells outside the line of the lungs. Lung cancer, which causes malignant tumours in the air passages of the lungs. And asbestosis, which is scarring of the lung tissue and marking by severe fibrosis. There becomes a risk to human health only when asbestos is disturbed and the loose fibres become airborne and they enter the respiratory system through either inhalation, ingestion, or direct skin contact. So the following legislation all relates to safeguarding employees from encountering asbestos, asbestos-containing materials during their day-to-day working lives. The Health and Safety at Work Act of 1974 is the primary piece of health and safety legislation in the UK, and it's what governs our methods of work. From this Act, there are several regulations which are part of UK law and place duties on both the employers and the employees to adhere to all safety measures and procedures put in place. The regulation that relates specifically to asbestos is the Control of Asbestos Regulation 2012. It includes land as a premises, and therefore asbestos in soil is now considered within this regulation, hence the growing involvement of the environmental consultancy firms and protecting this particular workforce. Other guidance documents for use specifically relating to asbestos in soil are produced by various scientific bodies. CAR Soil, which was produced by Clare in 2016, provides an interpretation of how the regulations within CAR 2012 apply specifically to works associated with asbestos-contaminated soil and construction and demolition materials. It provides guidance on how to implement the requirements of CAR 2012 in relation to site investigations and remediation activities, including a couple of useful decision-making flowcharts. Other guidance documents include ones published by the HSE and the AGS, including a recently published ground investigation document that talks more about risk assessments for ground investigations and laboratory personnel. There's also a couple of useful documents by Syria and a useful site guide for engineers that gives some little tips and information about how to deal with working practices with asbestos on site. SOBRA, or the Society of Brownfield Risk Assessment, has published their summer workshop meeting minutes and also a document which came out of that workshop from 2015. And the Joint Industry Working Group have produced some decision support tools, some Excel tools which are freely available online, which we'll talk about later on. So conceptualising the site is key to understanding the potential risks from certain contaminants. There are many factors that alter the risk in relation to asbestos, and all these need to be considered in a risk assessment. So these include the current site usage, so consideration as to whether the site is a brownfield or a greenfield site, has it undergone several phases of previous demolition. These may allow some insight into if and where asbestos has been previously used. Surrounding receptors should be considered and how sensitive they are to asbestos, as well as the asbestos type and form. So it should be taken into account whether the asbestos is bound in a matrix, such as asbestos cement, or whether it's in a fibrous form, like a lagging. The site activity needs to be considered. So are we undertaking heavily disruptive and disturbing activity, such as trial pitting, for instance? Ground conditions should be characterised. Soil that's more cohesive in nature tends to bind asbestos fibres to it, and it's not as easily released. This is also the case with moisture content. Water content dampens down the fibres and makes them less releasable, which is also linked to weather conditions. So wetter weather, as you can imagine, dampens down the soil even further, limiting the releasability of the fibres. So once we have a conceptual understanding of the site, we can then move on to the desk study element to further investigate the potential presence of asbestos. So asbestos-containing materials have been used throughout history in many forms and for many purposes, especially within the construction industry, due to the desirable properties that we talked about earlier. It reached its peak usage in the UK in around the 50s and 60s as part of various building fabrics. Therefore, it's bound to be present on most, if not all, brownfield sites that we come across today. And that's mainly because the sites we deal with generally contain dilapidated buildings or war-damaged buildings. They've undergone several phases of demolition. There may be deposits of made ground in basements, for instance, and they may have undergone some sort of importation of soil from an unknown source, or even fly tipping. It can also, I mean, we're talking about brownfield sites, but we can also not rule out the presence of asbestos on greenfield sites as a buried waste. So many of these old farms contain barns and outbuildings that may have poorly maintained asbestos roofs and walls, and they also may contain some sort of fly tipping or burial of asbestos-containing materials. Useful sources of information about the potential presence of asbestos can come from several sources. So the location of services and voids. If we know where services are, they may potentially have consisted of lagging, and voids may have become infilled with old basement, with old building materials, potentially contain asbestos. Asbestos building surveys are very useful, as well as previous site investigations that may contain data on the location and also quantity and type of asbestos. Consideration of the history of the site is also extremely useful. Landfills and railways, for instance, are more high-risk sites for asbestos than, for instance, a greenfield site. So the site walkover is a fundamental stage in the conceptualisation of a site and site investigation prep for any contaminant. During a site walkover, it's necessary for all site staff to do certain things, which can be taken forward in the risk assessment. So, for instance, inspecting the ground surface, any stockpiles of material or fly tip material, inspecting existing buildings for suspected asbestos is also useful. These instances should be noted on a site plan as suspected, as it's not always the case that we've proven that it's asbestos at that stage. On the plan, we should note the location, the form, extent and quantity of asbestos that we suspect, and also its degradation status, so how well maintained it's been over the years. Take ample photographs, which is always a necessity for any site walkover, and also note any areas that were not inspected on a site plan, as this may prove to be places where asbestos is present at a later date. We don't readily do it, and there are arguments to support not doing it at the walkover stage, but suspected asbestos may be sampled during a site walkover if it's safe to do so, and we have the correct equipment and PPE. So the site walkover and desk study information can then be used to facilitate the site work planning stage and the production of site-specific risk assessments and health and safety plans. They can also be used when considering the suitability of certain exploratory techniques. For instance, air flush drilling should not be used when drilling through made ground suspected of containing asbestos. The licensing and notification processes also need to be considered at this stage when planning site work. Generally, they're considered to be three types of asbestos work. So notifiable license work, where it's suspected that any control limit, the control limit for exposure to asbestos fibres is potentially exceeded, and there is licensable product likely to be on site, such as asbestos insulated board. Notifiable non-licensed work, which is dependent on the type of work being undertaken and the type and form of asbestos. In this scenario, measures in line with the licensing scenario, where a licensed asbestos contractor is needed, do not apply, but notification to the HSE will need to be done. The third scenario is applicable to most site investigations and sampling exercises that we undertake, and this is non-notifiable, non-licensed work. So in preparing for site work, mitigation measures need to be considered, and these can include several of the ones listed on the screen here, some of which can be done in conjunction with others. So it might be necessary to undertake a visible inspection of the ground surface before breaking ground to see if there's any visible asbestos-containing materials at the site surface. Standing cross or downwind of an investigation location to minimise the potential pathway of breathing in the fibres that may be in the air. Dampening down soils, which, as we know from our CSM slide, reduces the releasability of fibres. Inspecting soils in a hand-dug pit, putting up signage around the site just to allow other contractors or surrounding site users so that they know what's going on site. Undertaking air monitoring during soil disturbance, and this is shown by the top right image and the bottom left image on the screen. And these are small air pumps that are placed around the area of soil disturbance or around the site boundary, and they draw in a known volume of air. And then a surveyor will look at the slides under a microscope and count the number of asbestos fibres. This is done by the asbestos team. We have an in-house asbestos team at RSK who can also provide watching briefs during soil disturbance and inspect any soils that come to the surface. And obviously the use of PPE, so protective personal equipment, and RPE, respiratory protective equipment. So RPE and PPE are considered to be the last line of defence, and other control measures should be put in place to minimise fibre release, such as dampening down soils, as we've previously discussed. So RPE, respiratory protective equipment, includes the use of a half-face respirator with a P3 filter. These require face fit testing, so they're specific to the person who's using them. A full face positive pressure mask with a P3 filter can also be used. Again, face fitting is required. Both of these masks require the user to be clean shaven so that the seal between the face and the mask is tight. PPE includes the use of a disposable paper overall, usually a Tyvek Type 5 or 6 coverall, latex gloves or others, nitrile if is required by the user, and disposable overshoes or Wellington boots. These are used so that they're easily washed off and that any fibres don't become entrained in the shoelaces. So on the screen now is a general setup of a site investigation that we've done on a site impacted by asbestos. So as you can see, we've got a water bowser on hand to dampen down the soils, and also clean off any tools that have been used or drill casing so that we reduce the amount of cross-contamination. We've also got the drillers who are using disposable coveralls and Wellington boots, and they've got P3 masks on. We've got an air monitoring pump downwind of the intrusive location to monitor the amount of asbestos in air as a result of the soil disturbance. We're also using a nephelometer, which is a dust meter reading, which monitors the amount of dust, obviously downwind of the location. There's an asbestos consultant, surveyor, overseeing the works and inspecting any of the soils that come out of the ground. And we've segregated the work area as a dirty area, almost like an exclusion zone for the workforce, so that anybody outside of that exclusion zone can't get in and interact with them. So following on from this, we've just got a quick project example. It's an environmental and geotechnical site investigation at the former Turner Brothers asbestos factory in Rochdale. It's a derelict asbestos manufacturing and processing plant set up in the Spodden Valley. There's a woodland to the north and to the west, and there's a public footpath that runs right through the site from north to south. The actual factory buildings are in the centre of the site, which are currently structurally unsafe. So raw asbestos was imported via the railway in the north of the site and was woven and processed at Harwich Mill, which was in the north in the woodland. Any excess asbestos containing product or waste material was literally dumped in the woodland down the slope and ended up either on the slope or in the Spodden River. So there's been several phases of investigation over the years, and there's also been some remediation that was done in the late 90s. But because of erosion and slope instability, there's been trees that have fallen down and several instances of animal burrows, it's brought a lot of the asbestos waste products to the surface. And being in a public area, it's of great risk at the moment. There's all types of asbestos was noted to be present on site, all 6 types and in different forms and at quantification levels that are very high. So we were tasked with undertaking a site investigation to ultimately feed into the end development, which is hopefully going to be a residential development. We put in place several mitigation measures, which are listed here. So RSK asbestos team was on site at all times to watch what was coming out of the soil. We notified the investigation to the HSE just because of the type of asbestos that we were encountering. We did a site walkover prior to the investigation. All site personnel wore PPE and RPE. We did some background monitoring to see what the air conditions were like prior to us breaking ground, and then we did reassurance and personal air monitoring throughout the investigation. We dampened down the soils, and we chose to undertake the investigation in winter, so it was a lot wetter. We cleaned off all the equipment between locations. We tried to close off the site from the public, but only got temporary closure, so we had to segregate the work areas. And we set up a decontamination area, so a shower where all personnel on site had to go through at the end of each working shift. So just quickly, following that example, I just want to talk about these joint industry working group, the freely available Excel-based support tools that were produced a couple of years ago to assist with risk assessment mitigation measures. The tool is a series of Excel tabs, and on the first one it allows you to input site-specific details about ground conditions, asbestos type, air monitoring results, for example. And it then outputs in this format that you can see on screen, whereby it gives you a probable licensing status and an indication of the level of RPE recommended and whether or not dust suppression or decontamination is recommended. They're very useful tools and they're freely available, so I'd recommend having a look into them. So Moving on from the site investigation stage, we'll now talk about remedial techniques, of which there are many when it comes to asbestos containing soils. So the first option is to leave it in situ. This is likely to apply when asbestos containing soils are at depth and the public or future contractors are unlikely to come into contact with it in the future. But it is key to consider if future excavations are required to affect the areas, such as for foundations or for maintenance purposes, for example. Consideration should also be given in this scenario to future site usage, so it may not be inappropriate to leave it where human contact may occur, so such as residential gardens and utility corridors. But in this scenario, it would be prudent to use a capping layer, which includes a visual warning or a hard to dig layer, for instance. The leave in situ scenario means that there is a presence of asbestos on site, and this needs to be documented in an asbestos management plan and undergo agreement from the regulatory agencies. So moving on to a cover system, which we briefly talked about just then, but this is where a clean imported non-asbestos containing material and more often than not with the use of a teram, as is pictured in the top image there, is placed over asbestos containing soils. There's no statutory minimum depth, but it does depend largely on regulatory approval and the risk assessment, so it can range from 150 millimetres up to 2 metres in some instances. On-site reuse, this needs documenting, more than likely in a materials management plan. On-site treatment, this can include handpicking, where a suitably competent person identifies visible ACM and removes it from the rest of the soil matrix via screening or sieving or riddling. These activities all do require off-site disposal of the asbestos material. So it is likely that it would reduce the amount of hazardous waste going off-site, so there would be a cost saving, and it would allow reuse of soils, so it would be more environmentally and economically feasible. But unfortunately, it is more time consuming because you're having to actually handpick the materials, and it's not always appropriate in certain materials. So, for instance, fibrous lagging, where the fibres have become dispersed in the soil at a microscopic level, it wouldn't be suitable for this scenario. So off-site disposal, that's where the soils and the asbestos are likely to be needing off-site disposal at a suitable landfill facility. Obviously, it's quicker to just get it all off-site rather than separating it, and it might be more appropriate for the fibrous types of asbestos rather than the visible asbestos cement. But it is very expensive, and it's left with a deficit of materials, so you'd need to still import material to site. Soil washing is an option. I've not heard much about this and haven't seen it in action, but I know that some companies do it, whereby they rinse the soil of asbestos fibres. It's largely effective on granular soils, but it does leave an issue of potentially impacted wastewater and waste arisings. So some of the control measures to be put in place during remediation are very similar to those that are put in place during the site investigation. So you need trained and competent personnel. You need to demarcate and separate the asbestos removal area as part of an exclusion zone. All personnel should use PPE and RPE as required. There needs to be proper decontamination of equipment, including vehicles, so having wheel washing locations set up around the site, and having designated entry and exit points, so a one-way system, makes it a lot easier to control. Signage, as we've already said, and consideration for adjacent site users, and monitoring. So the monitoring is quite useful to be done in the remediation stage around the site perimeter, but also on personnel who are actually removing the asbestos. And there should be a final inspection by an asbestos surveyor and sign off for re-entry. Quick example of a remediation project we've recently been involved in was at the Greater Manchester Fire and Rescue Service, their new training facility in Bury. The site has undergone several phases of development when it was finally demolished in the 70s. Previous investigations indicated visible asbestos in the form of chrysotile cement, loose insulation and free fibres across the site. So we were tasked with undertaking remediation so that construction workers and future site users and maintenance workers would be safe during the ongoing usage of the site. So on-site activities during remediation included a licensed asbestos removal contractor riddling and handpicking the visible asbestos pieces, and we decided to exclude certain zones as red areas where only certain personnel could enter who were wearing full RPE and PPE. We undertook boundary air monitoring and also personal air monitoring on these workers. We dampened down the soils and undertook regular moisture content testing throughout the lifetime of the removal works. And we also undertook a phase of validation soil sampling so that as much of the material could be reused as possible. So the aim of the remediation project was to reuse as much material as possible. We used over 26,500 cubic metres of soil in the development, and over 6,000 of this was identified as containing above laboratory detection limits of asbestos. This material was buried at depth and recorded on an asbestos management plan. So overall, it was a successful project. So just to summarise, the legislation applies to all work with asbestos, including that undertaken with soil. CAR soil provides some clarity on how the legislation applies specifically to working with asbestos in soil. It's important to understand the conceptual site model in setting up your risk assessments. The Joint Industry Working Group provide these very useful decision support tools to assist with possible licensing and control measures. It's necessary to complete a health and safety plan and specific plans of work, and including in this a location of known or suspected asbestos. Site staff should undergo asbestos awareness training as a minimum, and also we recommend our staff carry face masks and Tyvek suits as standard in their PPE kits. And consideration of other control measures should be implemented to reduce and prevent the exposure and spread of asbestos. So thank you for your time. If you have any questions, I'll be more than happy to answer them. I'll turn my webcam back on now so that you can see me. Hello.
Thank you, Emma, for that great presentation and very interesting presentation. We have a few questions that are coming in now, and I'll pose some of these questions to Emma now. If you have submitted a question and it hasn't been answered, then we will look to try and answer some of the questions afterwards and email you back with answers. So, first question. What is the relationship between asbestos in soil and asbestos in air? Emma.
So that's a good question. So there's ongoing research at the moment to try and understand the relationship between asbestos in soil and asbestos in air. We're still working towards that. The hope is that one day we'll be able to find, get an answer for this, and to understand how much asbestos in soil is released, so the fibres are released, and actually are sort of the respirable fibres that we can breathe in to our system. There's a whole host of tests that can be done. I know in the US they do activity-based sampling, which is really useful, where they undertake an actual activity. I think they've played baseball on soil which has been impacted by asbestos, just to try and find out how much asbestos is released into the air. Those things are still ongoing in the UK as well, but it's an ever-growing industry, and we just need to get to the point where we understand fully the relationship between the two. Hopefully that's answered that question
Yes.
a little bit.
Are RSK able to undertake licensed work and non-licensed work? And with that goes, are all of your staff who supervise ground investigations non-licensed work trained or licensed work trained?
So RSK, we're not licensed asbestos trained, so we don't have that capacity. Our insurance doesn't cover us to do that. We can do non-licensed work, and our asbestos team, who are based out of Coventry, they have non-licensed surveyors who can do certain lines of work. But we would ultimately, for licensed work, we would go to a specialist contractor to do that. We do offer various forms of training. I know that our asbestos team give out various training sessions, and there is one for non-licensed workers. So we do have that training available from RSK.
Thank you, Emma. Can you use Site 1 materials as part of a cover system, say crushed concrete from demolition?
So you can do, obviously it would need to go through the appropriate testing regimes and also get agreement from the various regulators. So it would need documenting in a materials management plan, for instance. As long as the testing supports that it can be used within the development, then I don't see why not. We'd need to do an appropriate risk assessment to make sure that where it's being used and the likely, say, the end use, it all fits within a risk assessment. But there's nothing to say that it can't be reused, but it may just not be fully appropriate on that particular development. But it certainly needs documenting.
So I think a question that goes with that was, where asbestos impacted soils are buried at depth, should there also be a warning membrane in place above the material?
Yeah, definitely. So we've done this on several of our sites where we've laid so the last example that I gave, that remediation project, where the asbestos containing soils were buried at depth, we then put an orange marker layer. It was a sort of almost like a really thick geotextile membrane with the cover soils on top of that, so that anybody digging down through those cover soils, as soon as they hit that warning to ram, they knew to stop. They wouldn't necessarily know what was below it, but hopefully the documentation is kept on site. So we produce an asbestos management plan that should be kept on site, and you can then look back at that and see what that material is. So yes, I would always recommend using some sort of warning tape. Hard to dig layer is another option that can be used as well.
Excellent, thank you.
Yeah.
Is there a threshold for acquiring remediation? Generally, they said less than 0.001% in soil, or is it dependent on the site-specific conceptual site model or risk assessment?
Yeah, so this goes back to the first question of the relationship between asbestos in soil and asbestos in air. So unfortunately, there's no gap level, there's no threshold limit, there's no number set in place at the moment that says below this value, asbestos is fine to be placed at any depth on a site. So the less than 0.001%, I think a lot of people use because it's the laboratory limit of detection for most labs. But that isn't a standard, it's not recognised as a statutory value. We don't accept that in our generic assessment criteria at RSK as a value. So it does all depend on sort of your risk assessment and also the acceptance of, say, regulatory bodies as well. So yeah, this research is ongoing into the relationship between soil and air and what level of asbestos we can breathe in without it causing harm to us in the future. But unfortunately, there's a massive latency period of about 60 to 70 years until we know about what effects somebody can have from, working with soil. So it's very difficult, and nobody's willing to put a number on it as of yet.
Excellent, thank you, Emma. Is there anywhere in the UK or Ireland where excavated asbestos waste can get treated, or is it exported to another country for treatment?
I've not heard of it being exported to another country for treatment, and I'm not too sure where in England and Ireland we do that. Yeah, I'm really not too sure. I can certainly look into that. I'm sure we have colleagues over in Ireland who might know over there, for instance, and I can certainly have a chat with our RSK waste team to see if they know of anywhere. But I've not heard of anywhere specific where they do treatment for asbestos solely, so I'm not too sure. I can get back to you on that if you want.
No, that's fine. Thank you, Emma. There's one on PPE. They say the use of disposable coveralls in the investigation work. How would this work on, say, highway works, where obviously there's a requirement for protection from asbestos, but also then a requirement for high-vis coveralls or reflective jackets?
Yeah, we've had that fairly recently on a site where we needed to use a certain type of PPE. So it was all about sort of a risk hierarchy, and we actually determined that the risk from asbestos was greater. So we chose to wear our coveralls on the outside of our sort of high-vis jackets. But on other sites, we've actually used PPE, so coats and vests that we just got rid of at the end of the project. Unfortunately, the asbestos industry is quite a throwaway industry, and there's quite a lot of waste associated with it. So what we did was we had a secure lockup where at the end of each night we would put all our PPE that was on the outside of our coveralls into some secure bags, and then we could wear those each day, and then at the end of the project we got rid of them, so they weren't transferring onto another site, and we weren't putting them in our vehicles, we weren't taking them home. But on other occasions, like I said, we've chosen to put our coveralls on the outside of that equipment, and then we can just get rid of the disposable coveralls at the end of the project. So it depends really. You could do it both ways, but either way there's a lot of waste involved in it at the end of the day.
Thank you, Emma. So just a couple more questions now. You'll be glad to hear. Firstly, should the asbestos management plan be included in the health and safety file for the new development?
I think that's where it's kept. I don't think it's kept separate. I think it's kept in the health and safety file, which stays with the site for its lifetime, as far as I understand. So yes, it should be kept there. It should be kept with the health and safety file, most definitely.
And you mentioned about either soil washing or damping down of soils. So the when we've done this damping down of soils, or when we've done soil washing, is there particular requirements for how to treat the wash down water?
So it's a difficult one, because that is a negative for the soil washing remedial option, because you are left with that waste the waste water. What we've done before is we've left it to dry out, and then there's an element of soil arising, so the waste, the arisings that have left from the water that are obvious, that potentially contain asbestos, they can be tested, either disposed of as hazardous waste or reused at depth on site. So that is a downside for undertaking soil washing or dampening down. You do have that waste generation issue.
Okay. Thank you very much, Emma. So just before I wrap up the webinar, I would like to thank Emma very much for her presentation. Thank you. Can I remind attendees, please, to fill out the feedback survey that they'll receive shortly after the webinar. And our next topic in the Down to Earth series will will be with Dr. Sean Roberts on bringing former coal sites to development, geotechnical challenges and opportunities. So just before we wrap up, just to say, obviously, our asbestos colleagues can assist if you have any questions, as well as Emma, and also Envirolab, if you have any questions on asbestos testing and lab analysis, then contact Envirolab and they'll be happy to answer your questions. Okay, thank you ever so much, and we look forward to seeing you in January for our next Down to Earth.